Hi guys, just give it a minute or so to let people join and connect, and then we will get into it. Hopefully everyone has had a good day so far. It's always this like the initial period where you just are waiting. You don't want to start, you don't want to. So do you start bang on? I always like to leave it a good minute or so afterwards, just to the stragglers.
It definitely helps get people in here before we start.
I know I'm terrible for being at a meeting bang on. It's a All right, we will kick off. Thank you for joining us today. Today's technical workshop is on our SD-WAN product. So we're going to be doing a technical overview. As always with these technical workshops, if you guys have technical questions, please ask them in the chat. We will try and go through them and answer them. This will be recorded, so you can share it around after the fact. If you do have to drop off early or anything like that, you can rewatch it. But again, it is technical. We won't be going into too much sales or anything like that. If you do have a question, feel free to drop it in the chat though, and we can certainly try and answer it. So today we are joined by John Snowden. John is our from our vendor Fusion Broadband, and Dylan Frankie, our partner support manager at Hosted Network. I'm sure any of you existing partners will already know Dylan, the guru that he is. So Fusion Broadband is our vendor of choice for SD-WAN. We've been running the Fusion platform for ages now, right, John? Probably 4 years,
years now.
Years and years and years, 5 years. So we license the platform from Fusion Broadband. We run it in our core, which means that you can tie the Fusion Broadband piece of it in the SD-WAN platform into any of our products. So we can tie it into co-location, into firewalls, into infrastructure as a service, into voice, everything. But let's go through the agenda. So today we're going to be running through the SD-WAN architecture, sort of how it works and whatnot, and try and provide some context around that. We'll talk a little bit around SD-WAN best practices and how we compare in the market. All right, because like the term cloud, SD-WAN is a buzzword. It is not all the same. We will go through a technical demonstration, and then I didn't update that slide. We'll cover the provisioning process at the end, so you know how to order and what to expect there. So let's jump into first of all, what is SD-WAN? So with our SD-WAN product, one of the unique pieces of our offering is that we allow you to aggregate the bandwidth, right? So we don't just simply load balance, and we'll talk about that a little bit later, but we aggregate, right? So you think you have 2, 3 NBN connections, you're effectively making one pipe. You do a speed test, you get the full speed, right? You can also tie multiple sites together to develop a private network. So as many sites, that could be Azure, that could be our infrastructure, that can be sites on the home office, the corporate office, whatever it might be, all with point and click. So you don't necessarily need a lot of network engineering skills or anything like that. So it's your general technician should be able to support the product, as well as dynamic packet and steering prioritization. So we're going to look at the system will look at the packets and make sure they get to the other side when they need to, right? To make sure things like voice and all of those real-time protocols get the best experience possible, as well as you get a nice friendly portal and we're going to run through that in a bit, that will allow you to see the health of the underlying links. Now, like all SD-WAN products, SD-WAN is carrier neutral, right? So it's an overlay technology, which means that it runs on any connection, right? So it doesn't necessarily need to be a hosted network connection. We'd always love it to be, but there are many cases out there that they might be under contract. You want a primary carrier and you want a secondary carrier. for diversity, the SD-WAN platform will work with all of them. It will even work with, say, a Vodafone prepaid, cheapest chips 4G service, right? And it will provide a private IP address over the top. So all of that, I think I've covered most of it. John Dillon, do you have anything that you'd like to add there?
One of the ones I do want to cover is, because this is something that actually got one of our partners out of trouble, is when it comes to 4G networks, you commonly have the issue with VoIP phones where it's double natted and phones just don't work on it. VoIP does not like double nat. If you put SD-WAN in front of that, that issue's gone. Like, that issue is now null and void because it doesn't care about what technology or carrier it's using. It all just creates an aggregation tunnel back and bypasses that issue.
I'll move to the next slide just to sort of to cover that, because that's this one.
That's the public
here.
IP failover.
Yeah, well, how we provide that is this. So do you want to run through sort of the difference between, let's say, a Meraki, which they say they do SD-WAN, and John, feel free to jump in here as well, but how we differentiate from say, a Meraki platform to our SD-WAN offering.
So a lot of the other firewall SD-WAN vendors is generally more of a hub and spoke network. So you generally have a central firewall that all the sites connect back to. Whereas the Fusion Broadband one, our SD-WAN platform, we create a mesh. So like two Bondas.
Other way around. That's the other way around. Sorry, I'm being the big boss there. We provide a hub and spoke approach, right? So we have the aggregator piece of it in the data center. So we tunnel everything through that.
Yeah, but that's classified as mesh, Ben. Anyway, continuing. So generally speaking, a lot of the other ones, you'll have your head office router that everything connects back to and routes through that. And so, or have a co-located firewall or something like that. Whereas with the Bonda one, if you take the head office offline, all the sites stay online. They generally don't lose any routing. They'll just stop being able to route to head office and so on. But this also means you can add and remove sites incredibly easily. You just drop them in, set it to be in the PWAN, and it will go and update all the routing for you. You don't actually need to do very much configuration to get that going. Like I mentioned with the VoIP stuff as well in the previous slide, because we create that aggregation tunnel back to our data center, it means that your public IP remains the same, regardless of the underlying services. So you could have 4 TPG services with dynamic IPs, but that public IP on the bond will stay the same regardless, even if it fails over, switches to 4G, things like that. And we typically see a lot of customers as well. They'll get an SD-WAN bonder, set up with 4G, and then send it to site to get a customer out of trouble. So that way they can get the customer online.
And Dylan, actually, one of the things that I might jump in with as well, one of the things that we find really handy, or someone asked, a lot of people, ask this question, and they say, can you use this service behind like a satellite link or something really unusual? And the answer there is yes. It doesn't have to be a 4G or something common. If you've got a satellite service in the middle of nowhere, yes, you can provide a static IP address to a satellite link. And you can bring that satellite link into the private network as well. So that can be one of those sites on the multi-site network.
Yeah,
so really it's completely carrier and technology agnostic. And you can, I guess from where's my mouse gone? The aggregation piece of it, you can aggregate multiple different technologies, right? So you could aggregate, say, an Optus 4G and a Telstra 4G as one link with a private IP address that we provide from the data center. Now, you can't do that with a Meraki. You can't do that with most of the SD-WAN vendors out there, right? You're going to have this, so if you think of port forwards, if you think of DNS records, all of those things, they're going to break as soon as failover occurs, right? We don't care what the underlying connection is. As John said, you could have a satellite connection. You could have an NBN TC4. You could have a fiber connection, and you can prioritize them by all means, setting one to primary and others to failover, but we don't care. And it could be any carrier, right? It could be Vodafone, it could be us, it could be Telstra. So completely agnostic in that regard.
A good example of that as well is our operations manager, Luke. He lives in the middle of nowhere. He can get pretty terrible fiber to the node connections, but to get a fast speed, he's bonded 3 of them together to get a much faster speed that it's actually usable. So that is an option as well for customers who aren't in the world's greatest location for internet services.
I think John is actually going to use his connection as a guinea pig today, and I hope that we told him that we're going to use.
I told him beforehand. I told him beforehand, so he knows. Last thing we need is him rebooting it while we're doing tests.
Cool. Okay. We actually got some questions coming through here. So how much can we actually aggregate? Good question. That will depend on a couple of different things: the hardware that is provided on site and the underlying links themselves. So can you bond 2 gigabit connections together? Technically, you can, but engineering is required, right? So that's a good question, Aaron. We typically need to engineer that. The out-of-the-box use case for these things is, your NBNs, your active failover sites. The joys of working from home. My dogs have gone nuts. So can we do high-speed connections? Well, no. Sorry, postman. Yes, we can. But there are different things to consider. We'll go through the hardware and talk about the technologies that you can go up to when we get to the hardware a little bit later. But the thing I sort of wanted to highlight there, and John, maybe if you can answer this a little bit, but can you talk us a little bit through what the difference between aggregation and not load balancing? Why is that different? Why is it important?
It's important because load balancing will basically, it's a flow-based technology. So, the example would be, let's say you are uploading a video to YouTube or something like that. And let's say the person next to you is uploading a video to YouTube as well. You start yours first, and you might have 2 internet. Let's say you've got 2 NBN services. A load balancer will typically take your internet flow, your flow of traffic, and assign that to one of those NBN services. And it will just flow up that one link. The next person will go and do their upload, and then the router that you might have will then intelligently say, okay, this link is a little bit busy. Let's put that up the other link. But it doesn't put it up, push it up both links simultaneously. So what the difference is with aggregation is that we do what's called a per packet aggregation. So we look at all the tiny little individual fragments, and then we push them up both links simultaneously. Now, I'll give you an example, and that is that if you have a service, or you're looking at a service which is a router, someone is selling you a box that can do aggregation or whatever they say it can do. It cannot do true aggregation unless there is something at the other end. So when I said we're doing proper per packet aggregation, you push these fragments. They mean nothing. They're these little gibberish little fragments up both links, but they have to be reassembled into something that is actually a meaningful flow on the other end. Otherwise, these little random packets just fly into the nowhere and they just get lost. So you actually have to have an aggregator or a central data center piece, something on the other end that can accept those packets, reorder them in the correct order, and let them then continue on to their destination. And the same thing has to happen in reverse. If you want to increase your download speed, you have to have these flows hit some central device, which will then split those packets, push them down your multiple links, and then your on-premise router will then reassemble and hand them to your computer. That's exactly what Fusion Broadband does. And on the technical level, because it is a technical demonstration, there are technologies where you can attempt to do this sort of thing. Cisco's been doing this sort of thing, a long time ago, where they were using something I believe called MLPPP. It's a link sort of aggregation protocol. But the problem is it wasn't built to expect differences in latency, differences in speed, different types of connections. If you tried to bond 2 4Gs together, for example, it would just break because you run into something called out of order packets. These packets would be pushed up the links, and they had to arrive at the other end at the same time. Otherwise, they would be out of order and the whole thing would break. This is something that's been a big challenge for people since the dawn of time, but we built our solution to expect out of order packets. And that's why Hosted Network's solution when it comes to aggregation is so far ahead of what came before it. And that's my basic take on the aggregation versus load balancing, per packet versus per flow.
And I think that they're two of the main, the public IP address piece of this here and the aggregation, not just load balancing, are two of the big things of how we differentiate versus, say, Meraki, because I know that we've got a lot of partners that use Meraki out there, and there's certainly a place for those. But when it comes to, needing more bandwidth, needing that seamless failover, right, being able to provide aggregation in the public IP address. Good example, voice calls. So Dylan, tell us a little bit about what happens on a failover from a voice call with us versus, say, a Meraki.
So say you've got your two connections, you've got your fiber link and a 4G backup, and you've got a voice call going. If your fiber link, say someone cuts the fiber outside of your building, you might notice one or two, like half a second or a second of drop in the voice call, but then it should pick up straight away because the public IP is not changing. So the destination source is still the same. It just takes a second for it to switch over, which in most traffic is not noticeable, but VoIP being sensitive,
And
it does pick it up.
right?
Yeah, and it's in real time.
So you think that could be an RDP session, that could be a Citrix session, yeah.
So it does switch off seamlessly. If you had two primary legs bonded together, you may not even notice it because it's just going to go, the first one's offline, I'm just going to push everything down the second one without anyone noticing. Because it's, as John said,
what would happen with one of our, other, competitors in that regard?
You're most likely your VoIP call is going to drop, your Citrix session would drop, anything that based on real-time traffic would drop, and you would have to reestablish because, as Ben said, it's not aggregation, it's load balancing. It's so your public IP is going to change.
Yeah, you hit the nail on the head in that source and destination piece of it, right? So, with SIP, right, or with VoIP, the SIP protocol requires the registration to maintain. It needs to know where it's coming from. If all of a sudden the voice call is trying to connect from something, it's it's like it's trying to go through a different door and the door's closed. The one that was open is, all of a sudden they've gotten confused and lost. Great. Okay. So the other pieces of from our side, we provide a fully multi-tenanted portal, right? So you guys can manage all of your SD-WAN customers in addition to our partner portal. So you can manage the service from there, but you can manage the configuration from a multi-tenanted portal. Think of the exact same way that we do if you know our voice offerings or if you know our IaaS offerings, right? All of our products are designed for MSPs with MSPs in mind, right? Being an MSP originally back in the day, we know what the pains are like when you're trying to deal with, product A that you have to, log into each and every single different customer. So, we position service offerings that are going to be multi-tenanted to streamline your management, as well as simple licensing. No one likes a bill of materials with 100 different, items on there. It needs to be simple, right? So we provide this as a flat monthly fee with all of the features available to you. All right. So it's up to you whether you use them or not, but they're available to you and we don't charge you extra for them. Cool. Okay. So if I can get out of the annotate thing and go to the next slide, Dylan, run us through the architecture. How does it actually all come together?
So the diagram just depicts a very simple one SD-WAN site. If it was multiple bonders, you would essentially replicate the customer site multiple times and it would connect back to the aggregators that way. All of the WAN connections connect straight into the bonder because it's the bonder that's managing the authentication, managing the routing across that aggregation tunnel. So as far as a firewall or UTM on the site is concerned, it's just got a WAN connection plugged in. And we can configure that WAN connection a bunch of different ways because different firewalls like a different type of configuration. The only thing that the bonders can't have connected straight into it is a VDSL connection because they do not have a VDSL port. So you would need another router in bridge mode just sitting in between there. But in saying that, you could connect any service in there as long as it comes off with an RJ45, whether that's PPPoE, DHCP, static IP, all those will work. But it will essentially, the firewall will push everything to the bonder. The bonder is going to split it up and aggregate it, push down that aggregated connection. And then from there, you can, as the diagram shows, connect it into our IaaS platform, connect it into, say, a Sophos or FortiGate managed router in the data center, whether that's virtual or physical. Or you can even push it down Express Connects to Azure or through another connection to AWS and things like that. So the platform is very flexible in that sense as well. And because it's all managed by us, we can also design the solution to cater to exactly what the customer needs. So if you need something very bespoke, there's a pretty good chance we'll be able to do it. Just requires a bit of engineering work.
So we like to refer to our service offerings as sort of building blocks, right? So, and we don't have, like our SD-WAN product is powered by the Fusion Broadband piece of it. We don't, so we skill in that area, but it means that we can tie that across our entire network. We run a national network, data centers out of Sydney, Melbourne, Brisbane, and Perth, right? So we can take connections in there. We can then push them across our national network out wherever that may be. And with the SD-WAN piece of that means that can be any underlying connection. Right, so it doesn't need to be a connection from us. It can be, 4G. It could be anything like that, and we can bring that all the way back into Azure as an example via a private link.
And Aaron's just had a very good question. Do you need a firewall or UTM on site, or can you just use the Bonder as just the router on site and route everything back through to a UTM hosted with us? You don't actually need a Bonder a UTM or firewall on site at all. The Bonder itself can act as a router. It can provide the DHCP and everything, and do all the port forwarding, which is managed through the Entirus portal. So this guy here. So if you would prefer not to have to manage a router on site, you can just choose to have the Bonder on site and manage the config through here, because this will also store the configuration for the Bonders, which means that if the Bonder dies, you send a new one out to site, pop in a key, and it'll re-download the config exactly as it was last time it was online. So you don't have to worry about documenting the configuration or exporting config files or anything like that. But in saying that, like Aaron asked, you can actually have it so that the Bonder just comes all the way back to a hosted solution and manage the firewall here. And you could do that for a 15 site private WAN, PWAN. So all of those sites can terminate back to that UTM. Obviously, you need to make sure it can support that much traffic, but you've got the option there.
So do you need a firewall at all? Good question. Yes, you always need a firewall.
Security-wise, yes.
Yes. Disclaimer there, big red disclaimer. You should always have a firewall. The device will do basic firewalling, right? So we're talking, traditional firewalling, not UTM. Right, so it isn't going to be doing your application aware like a Sophos or a FortiGate or anything like that. It is always our recommendation that you should be using one of those. The benefit of this solution is that you don't necessarily need to have multiple of them running at the local site, right? You can, like Dylan mentioned, you can move this to our data center. All right, and that can be co-located. We've got customers that co-locate their firewalls, or their equipment, or it runs virtually on our IaaS stack. And it means that you can bring in each of those sites behind them, keep the cost down, keep the management piece of it down, and protect all of those sites. So do you need a firewall? It has a firewall. What you need is a UTM. Hopefully that answers that question.
And one other thing I just wanted to quickly mention while we're on this slide, because it comes up every so often, is certain customers will be brought over that say their VoIP platform is locked to a public IP that is with their internet provider. Take TPG, for instance. Usually if you get a phone system from them, your phone system is locked to that internet service. What you can do in that instance is on the Bonders, you can do a classification profile to do a tunnel bypass. So instead of saying, oh, all the traffic goes up the tunnel, you can say all the traffic except traffic to this destination goes up the tunnel. So then your normal traffic will go up here, but then to that VoIP server, it'll go straight out, bypassing the tunnel. So that way you don't have to fiddle around with getting it to work with TPG or anything like that.
Can also be good for backups and things like that, right? You may not want you may have a big fat pipe that, you don't want to have to push everything up the pipe to the data center or to our aggregators. You can just bypass that directly. So if you've got, things like a layer 2 or an MPLS that you've got those sort of sites, that configuration set up, you can get creative with that. You don't need to, obviously, out of the box. It's very simple to set up, but you can really get into the nitty gritty of it. And then we're obviously there to support you and help you with that engineering when those, curveballs come at you.
And I don't know if we we cover virtual bonders in a previous slide?
That is the next one. So John, I might get you to run through this one. So let's talk a little bit about the hardware itself. Well, as Dylan said, and the software.
So again, keeping the technical feel going, the software itself runs on the operating system of Debian, of Linux. So it's running on Debian. And our software that we've developed runs, it's basically an overlay, it's on top of Debian. So what that actually means is that our solution basically runs on pretty much anything. So we have virtual bonders, which runs the exact same software as what is running on the rack that you see. It's the same as what's running on the Edge 200, the Edge 400. It's the same software. And that's why we can also run that in Microsoft Azure, in AWS, in Google's platform. Wherever you want to run that, you can run that. You can run it under Hyper-V, under VMware. Doesn't matter. It's just basically Debian with our software inbuilt. And we have an ISO file for that. Now, what we also have is the CPEs, or what we would call the nodes, and they are the devices that would go, of course, into the customer's premises, these edge devices, as they're called. Running through them, basically, we think of it, we have a small, a medium, and a large. There's a few other ones that you don't see on the screen, which are really for, as Dylan mentioned earlier, bespoke sort of rollouts. But basically, you've got your small, your medium, and your large. The small, we say that it goes up to about 200 meg in total throughput. It'll actually do more, but that's what we advertise. 4 Ethernet ports on there in total, and you can do with those what you will. So you can have multiple handoffs to your LAN. There's good examples is where that can be used. Or you could have, let's say you would have up to 3, let's say NBN connections bonded together. You could do that, 1 for the LAN and 3 WANs. You've got your Edge 400 box. That is actually rack mountable. So it comes with a rack mount kit. I believe that is the hosted network standard, the Edge 400.
Yeah, that's our default recommended piece of it.
Yeah.
You know, the Edge 200 is the typical go-to for us for your failover services, right? So if you don't care so much about aggregation and you just want a nice, tidy, seamless 4G failover service, you know, NBN connection in as your primary, 4G service with us or whoever it might be as your you know, failover service, you know, and that can either go into the USB port or into the secondary WAN port.
Yep. And the Edge 400 in terms of throughput, because really that's all we're talking about. It's throughput capability and how many physical ports are on the box. So there's no artificial slowing down of any of your links at all. It's just how much processing the CPU is capable of, basically, on the box. So you want more capability, you just need the right type of hardware appliance. The Edge 400, we advertise it goes up to about 400 meg. Behind the scenes, we've tested it up to, well, over double that, but you know, we like to be conservative, because the other thing to remember is the more features that you turn on, the heavier the load on the hardware. And I'm talking about you know, quality of service and compression and things like encryption, so 256 AES encryption and so forth. All of those things tax the CPU just that little bit more. So we like to be very conservative. So we say up to 400 meg. And of course, then you've got the rack above, and that will do up to 1 gig of throughput.
Think of this like, I'm just going to say, jump in there, John. Think of it like if you're sizing a firewall, right? The more features you turn on, or like, sorry, not a firewall, using the UTM term, the more features you turn on, the bigger the box that you need. The less you turn on, the more throughput you can get. Yeah.
So the other thing that's really important to cover off at this section is, one of the questions it would normally be, okay, well, I've got this box. Is this now my single point of failure? And you'd say, well, yeah, you're right, because if the box breaks, well, everything stops. Fair call. But of course, we offer you, you know, high availability. So if you want to, you can actually have 2 pieces of equipment that will work in tandem. If one of those boxes was to break, the other one would just continue on. So you've got one active and you know, primary and sort of secondary at all times. And automatically, if one drops, the other one will take over, and away you go. So like, yes, like
a FortiGate HA or something like that, similar features.
Yeah, that's right. And if you want to get very, very technical, there's VRRP protocol. You can actually do handoff by BGP. That's how you can do your failover, your high availability. Or we also like to use a piece of Debian software in the background called Pacemaker. So that's how you would do the HA.
Yeah,
but
cool.
definitely speak to hosted network if you need that.
Will we be covering pricing for the unit services during this webinar? No. If you speak to your account manager, that would be the best person to go to for pricing, or access the partner portal. Everything is available to order online via the partner portal. So you can just you can punch an order through very, very quickly.
What it is worth saying is the pricing compared to a lot of the other devices out there from other vendors is very, very attractive. So definitely chase down that pricing, because you'll be very, very pleased.
Yeah, the reason we won't cover pricing this is just because we may have some non-hosted network partners on the line, and it's in terms of commercial and confidence for those partners to keep them competitive in the market space. It's only available for hosted network partners. So. Cool. Okay. So John, next one, we're nearly at the demo, guys. We're nearly at the demo, and then we can run through any of the bits and pieces there. But let's talk a little bit about tuning and sort of how some of the smarts that kick in.
Yeah, so one of the things that I really love about the solution, and when I first jumped over to Fusion Broadband, I really got deep dive. I did a big deep dive into the tuning aspect, because I just loved it as a technician, and my background was working for an MSP as well back in the day. So to give you an example, speedtest.net. You all run speed tests. I know you do. We all do. We all love to know how our internet is performing, and often we go to speedtest.net. When you go to speedtest.net and you start your test, you'll notice that the first thing it does is it tells you what your latency is. And it might say 10 milliseconds, 20 milliseconds, whatever it is. And then it starts the test. And it says, oh, yes, you can get 50 meg down and 20 meg up. What really happens to an internet service, once you get to the maximum upper limits of the service, it doesn't perform the same at each speed level. So let's say you're capable of 50 meg down. It doesn't, behind the scenes, it does not perform the same at 50 meg as it does at, let's say, 20 or 30 or 40 or 45. So what we like to do is tune a link. So I want to explain to you the image that you see on the screen. This happens to be a tuning result from an old ADSL, an old ADSL service, and it happens to be the upload speed test. So you've got we'll ignore the gray line, but if you look at the dark blue, that's an indication of the actual throughput that we were getting. So as we pushed the link harder and harder and harder, you'll see that the speed was going up and up and up and up and up on a very nice gradual curve. Now that's what you would expect, but you get to a point right at the top where you see 0.9, where it just flatlines. It just can't go any faster because you've hit the upper limit. But on the bottom axis, you'll see that we did a speed test. We started at 0.2, 0.3, 0.4, and so forth. But we got to about 0.9 meg. And you can see that's where it really plateaued. The dark blue line plateaued. But notice, we tried to push it harder and harder and harder. And you can see the light blue line went up and up and up and up and up. The light blue line is the latency. So going back to speedtest.net, they tell you what your latency is before you run the test. We like to know, how does the link perform latency-wise when your link is under load? It's really important, because what happens when your latency goes bad? Your voice quality goes bad, the responsiveness on Citrix sessions and so forth, anything real-time starts to become a problem. So we basically tune your links. We see at what point in the download and upload does the latency and do the, where do we get into the danger zone, you could say? Where do things sort of start to redline? So if this was a service that was really, really conscious on having the lowest latency and most consistent and responsive internet service possible, I wouldn't set this very much more than 0.8 meg. Yes, you might do that 0.85, that halfway in between 8 and 9, but I wouldn't go any higher, because you can see that the latency actually starts, it's probably about 25 milliseconds, but the very first time it hops up, it goes to about, I don't know, let's say about 40 milliseconds. Then the next hop is about 75. Then it goes up to 300 milliseconds, and then almost 350 milliseconds. You can't get into that zone. So with the portal and with this system, we tune the links. We make your links perform better than if you just let them run wild. Because when you've got a standard internet link just behind a standard router, you don't get any of these benefits. And this is all something, you know, this is behind the curtain. You don't normally get to see these sorts of analytics. And we provide you the tools so that you can make the right decision for your customers in terms of tuning. You might want to give them more throughput, or latency might be more important. And we'll show you in a moment in the portal where you can do that sort of tuning. It is an automatic process, but you as a technician can get in there and have a good look, and you can make those intelligent decisions and build the best type of internet connections for your customer.
Cool. Thank you, John. Good. I guess adding to that as well, you know, if you think of say 2 NBN connections, right, and you're trying to aggregate those, if one of those connections all of a sudden hits that latency, everything goes to hell, right? And so that's where that threshold sort of comes in. And if anyone's had a ping test going when they do a speed test, like if you just get like a ping, you know, 8.8.8.8 minus T, and you'll see that latency, it'll jump right up when the speed test starts maxing out. So, you know, like John said, that's going to kill your voice connections, things like that. So this automatically is taking care of that for you.
I think there's probably one other thing to highlight at this point too, and that is that you might say, okay, I'm running a 4G service, let's say, and at different times of the day, I can tell you that it performs differently. Sometimes I get more speed, sometimes I get less. The latency can be all over the place. So that's also been taken into account. There's a feature that you can turn on in your portal called bandwidth adaptation. And we can highlight where that is a bit later too. Bandwidth adaptation. When you turn that on, the service will look at that link and it will look out for any latency or packet loss related issues. And if it finds some, it will try and fix them. And the way it fixes them is basically to slow that link down temporarily until the issues go away, and then it ramps it back up to full speed. And that's something that can be very important if you've got a residential connection that just performs horribly at 7:30 at night when everyone's watching Netflix. Better way around that would be to get a hosted network internet connection. But if you're stuck on a contracted residential, you know, there's some avoidance practices in the back end as well that take care of that.
Cool. All right. So another one for you, John. Let's talk a little bit. And I think this is the last one before the technical demonstration.
Yeah, it is.
But sort of let's talk TCP acceleration.
Okay, TCP acceleration. So a few analogies will come into this one. But basically, whenever you want to have, hey, we go back to speedtest.net. The other thing that you see with speedtest.net is when you run that speed test, just before you hit the go button, you can also see single flow versus multi-flow. To get a true, accurate representation of what your service can achieve, you want to do a single flow. You don't want any smoke and mirrors. So you do a single flow and you do your speed test. Now, this is a real life example. On the left is like a single flow type of test. Now, this was a congested internet service. I don't know whose it was or whatever it was, but we did a single flow test, and you can see the throughput, the average throughput we were getting was about 22 meg per second on this service. That's all we could get. Now, we have something called TCP acceleration, which basically converts your traffic from a single flow into a multi-flow stream. When we did that, when we turned on TCP acceleration, you'll notice on the right-hand side, we were getting almost, say, 37 meg on average. That's a huge difference. So to give you the analogy that I like to use on how we actually achieve that, if you assume that you're with one single internet provider, whoever that might be, and it's congested, you're all driving semi-trailers, big trucks, and you're just in a big traffic jam, and you can only get your 22 meg because you're just battling everyone else on that road. What we can do is we can convert your semi-trailer into a swarm of motorbikes. And what you in essence do is you fill the gaps. You get some that go up the sides, some through the middle, you duck and weave, and we're able to better utilize that congested link. So that is another really cool feature that you have access to. And it's a very simple on and off toggle that you get in your portal. So again, we'll show you that shortly.
Cool. All right. Well, I think that shortly is now. So I will stop sharing and I will let you share, John.
Wonderful. Okay. I will jump in and and share that screen for you.
So guys, for those of you that are techs on the line that are already using our SD-WAN offering, perfect opportunity if you want to sort of get further details on something or even how to, just let us know and we can run through those for you.
Okay, so this is just a quick view of your current portal. This is probably the last time you'll see a technical demonstration, I'm assuming, with this portal, because that's being redone. There's a big upgrade coming, which is very exciting because there's some very cool features, but we'll let you know about that in due course. You will see typically in this portal all of your customers. You'll see the current throughput rates of what's happening on their service. And at a glance, you can have a look and see that this site has 3 internet links. 2 of them are online, 1 of them is not. And the gray box just means that it's in failover mode. So that would be like a 4G backup, for example. I'm going to open this site, give it a double click. I'll show you some of those features that we just spoke of. So firstly, you'll notice down on the left-hand side, QoS, compression. So we basically do approximately 400% compression. So if there's something that we can compress, it will compress it and you get a big speed boost out of that. TCP acceleration, that's the multi-flow. That's that congested link enhancement that we just spoke of. And all you have to do is tick the box, just click the little box and it happens straight away. Tunnel authentication, that's all to do with AES 256 encryption. But any of these settings that you want to turn on, they happen instantly. Unlike used to work on MPLS networks, and you'd make a change in a portal, and it would take about half an hour for that to propagate down to the box. Anything you do here is instant. So if I click that little box, turn on compression, that is now active down on the CPE on the node. So I'll turn that back off because this is not my profile.
That's all right. It's our operation manager's house, so I'm sure he's just he's loving it.
That's right.
We didn't give him much choice. We've actually got someone in the messaging saying shut his house down. We really could.
So, and the same thing here with failover. So this link is probably a 4G, this E3 you see, and that's in failover. If I wanted to bring that in to try and enhance and try and add a bit of speed, if I had to, I would just tick that box and that would instantly become a bonded link. Very quick and easy. Bandwidth adaptation. That's exactly what we were talking about when it came to that latency and packet loss. If you start to see latency and packet loss issues, we can turn this on. Again, all of these things don't interfere with the customer technically. They don't know that this is being toggled on or off. Everything keeps working. And this will now monitor that link for any issues and will take action if it sees any. So another feature that I wanted to show you was the graphs, but I also wanted to show you a bit of an example of troubleshooting, what you might do. So this 4G, I noticed that this is down. Okay, so you might say, okay, that's down. How long has it been down? So one of the features you can look at is a 24-hour graph. Okay, a lot of people don't know that this is here. So next to E3, these little blue circles actually have a function. So if I was to click on that link and I click on the blue box, it will actually open up and show me a 24-hour graph. So I can actually see that this service has been down for at least 24 hours. Interesting. So then it begs the question, well, if it's been down for a whole day, how long has it been down for? This is where you can now start to look at your graphs. So 15-minute, 1 hour, 6 hour, a day, a week, a month, a year. So you've got a lot of graphing. Let's not muck around. Let's go straight to a year's view. Best way I find to actually have a look at a link when it's been up or down for a prolonged period is to actually look at the latency graph. The link isn't online and therefore there is no latency, but what you can do, you can deselect the 2 primary links. I just want to look at the 4G. When was it last online? Hey, there's no data, meaning it hasn't been online in a whole year. So if this customer has their NBNs go down, fiber to the node, someone drives into the node, this customer will not have a 4G to hold them up. Speaking of that point, then you think about alerts. So yes, you get alerting. You can send an alert to multiple different email addresses and so forth to actually advise you when a link goes down and when it recovers. It's all to do with this little button up here, configure alerts. And you can actually send the alerts to individuals or to groups. And you can look at your alert history, which I won't bother opening. And you've got your little alarm bells. So you can actually say, look, I'm sick of getting alerts. I know that that's down. It's not coming back. So I'll just pause that alerting and it won't bother me for another, for 6 months until I actually plug one in and I'll reinstate it. Now getting to the speed tests. So I showed you the graph earlier where you actually saw those speed tests. We pushed harder and harder and harder, and what happened? So I'll show you a couple I did earlier just to save time, but you have a speed test tab and you can come into here and you can actually do tests on the individual links. In fact, you can even do bond tests. Now, a highlight is that I did a speed test before this webinar. And what I did is I did a no rate limit test, a download test. I basically said, download as hard as you can with no rate limit, just go as hard as you can. And it's a perfect, beautiful looking internet service. So I first thought, well, this looks great. And then I had a look at the latency. The average latency on a 10-second test was 40 milliseconds. I thought, okay, that looks actually quite good. Can we improve on that? I doubt it. So then I decided to put a rate limit in of 20 meg. I said, do the same test, but rate limit. Don't go any more than 20 meg. It's just an example, but I had a look. Yes, it still looks perfect, but look at the latency now. The latency dropped by more than half. If I tune this link properly, I will have twice as good latency as what I have right now when the link is under load. The last thing I just wanted to very quickly highlight is, of course, these speed tests and this tuning can be done automatically. And all you have to do is select your link on the right-hand side and say, detect speeds. And that will go into an automatic tuning run. And that will tune this link right now. And because that link has never been tuned correctly, I'm just going to let that go. And I'll attend to that later for this connection. And unless there's anything you want to see right now, Ben, if there's anything you want me to show, I would probably jump back.
Well, just stay there, I guess, just before we sort of move to the next step. You can see here that I'm just going to draw on your screen, John. Give me a second. We've got the key. So we're going to talk about that in the provisioning process, but effectively, when you order one of these, we drop ship the box to site. And Dylan mentioned a little while ago, that key associates to this bond profile. You plug that key in, everything gets downloaded, right? So there's no, you don't have to configure every single device. It also makes it much easier if you're doing, multi-site rollouts. You ship the boxes out, you pre-configure everything, and, away they go, done. All right, so nice and easy there. Yeah, so I just wanted to point that out. We'll cover that in a second. Dylan, is there anything else that you want us to cover there as well?
I was going to suggest if we could quickly go over how easy it is to add another leg. Say if you only had one NBN service on site and you wanted to add a second one. I was about to say you couldn't because of the tuning, but
that's okay. We'll just cancel it.
So if I was to bring on another connection, say I had a static IP, how easy would that be to set up through the interface?
It's really simple. It's really simple. So all you have to do in this leg section, this is the leg. So all you would have to do is just come in here and say add a leg. And now let's say it's a DHCP.
Yep.
It's nice and simple. Or the only real thing that you have to do, I mean, yes, it's good to put down a speed. What is the speed limit? But really, the only thing you really have to do is put in, which port, which interface will that live on. And that's down here. So it might be on, I don't know, let's just say E6 on port 6. And that's basically all you have to do.
So if it was a PPOE service, you'd enter your PPOE authentication details, etc.
And just on that screen as well, we can adjust the bandwidth adaptation limits. So like John mentioned earlier, how much it brings it down in order to try and reduce the latency or packet loss on the link if bandwidth adaptation is enabled, as well as the threshold at which the bonds will automatically remove the leg from the aggregation tunnel if it's having a certain amount of packet loss.
So a good example of this one, this one's obvious. This is our operations manager's home connection. So he's got his whole family running from it. And at times they care more about Netflix than they care about latency. So in those sort of circumstances, you don't want bandwidth adaptation on because it's going to lower your speed, right? But if you're in an office situation where maybe speed is less critical, what you care more about is latency. That's where that really comes into play. Whereas if you want to stream 4K at Netflix at 4K, well, that doing so, maxing out your connection is going to introduce latency, which will impact real-time services. Less of an issue for home services, but kind of critical for business.
That's right. Just confirm and actually add that link because it's not going to harm anything. And now we have an extra link down here.
So you just plug that in, John, the way you go.
Yeah, you just plug yourself a service. That port will be listening now, waiting for to be given an IP address because we set up a DHCP, and you'll instantly be online and will be bonded with the other links to increase your speed. And if it's relevant, let's just say you've put that in and then your ISP says, oh, we forgot to tell you, this link has to be on a VLAN 100, for example. That's quite common. How do you do that? It's very simple. I'm just going to edit the leg. Come down to that interface. And if I want this to be VLAN tagged, it's as simple as just putting a dot and then whatever the VLAN is, VLAN 100. Save. That's it. Done. Finished.
And
So,
from memory, you can do the same thing for LAN interfaces, right?
Most certainly can. So ETH0, this is the physical cable that is plugging into the switch on premises. If you wanted to add another one, or even if you wanted that subnet, for example, to be on a different VLAN, and I won't save the settings on this one, but you would come in here and just put in .100, let's say, and hit save.
Okay. And so in the
simple.
situation of like if a leg fails or if you remove a leg, does that have any impact to the tunnel?
Not at all. So if you unplug a link, everything keeps working. Again, if you're on a voice call and you've only got an NBN and let's say a 4G and the 4G is just in failover mode, if the primary link drops out, we have a less than 300 millisecond failover timing. In fact, we can actually change that timing to make it even lower. So I've done a lot of technical demonstrations where you actually see not one single dropped ping packet if you're looking at a continuous ping when you actually fail that over. But typically, we leave it at 300 milliseconds, and there's a very good reason for that, because if you have a 4G failover, we're constantly sending tiny little pings, little heartbeats along there just to make sure it's still alive and that we can see that data packets are still running over that link. So that uses up data, even though they're tiny packets, and at the rate of 300 milliseconds, we find that that uses up about, I think it's just under 50 meg of data per month. The smaller you, or the quicker you make that failover timing, the more data that gets consumed because you're pushing more of these little keep alives up the link.
Yeah. Okay. So if you've only got like a 1 gig data plan, or you've got you're paying per gig, that might add up.
That's right. And so that's another configurable option where we can even make it more, because hey, 300 milliseconds, you don't even really detect that on a dropout call. So you can actually increase that if you want to 600. Yeah, nothing will drop out.
All right. Do we have any questions so far? I don't think we do. Just looking through. All right. Well, what we might do is we just quickly talk about some of the upcoming features. I think John mentioned that there's a new portal. So the new portal is coming out soon. So the UI there that John's just presented will be changing. And I think, are there any new features coming out? Well, I guess I'm about to share one on the screen. So let me do that first, all right? Okay. So John, new features. Talk us a little bit about this.
I'll speak to what's on the screen first, and then I'll go through a couple of the other little features behind the scenes. There's a lot that's coming out that we just won't have time to cover. But yes, the portal has been completely reworked from the ground up. That's in progress, so that'll be out soonish. What will be out very, very soon, we're talking weeks or even in the next month. It's already in the background, but yeah, we just haven't released it to everyone yet. is all of your analytics. So you can see, which computer is going to YouTube the most, what are the top consumers of bandwidth in terms of computers. You can have a look at the applications. So which applications are using up the most bandwidth, which sites have been viewed the most versus the amount of bandwidth consumed at each site, et cetera, et cetera. The type of analytics you would normally see, layer 7 type of application awareness. That's coming in. Now, the other thing that I really like about the new system is we have other things as well, like VPN detection. So a few people have said, oh, we really like that. What is that all about? So think about a customer of yours who is, you as an MSP partner, you manage your customer, and you might say, well, there should be no VPN traffic exiting this site. This is very unusual. So if there's any VPN tunnels associated with hiding content, you can actually have a look, and it will tell you each device on that network which is establishing VPN tunnels outbound, and that can be a really nice little early warning sign. Similar thing too, where let's say a customer was, one of your customer's employees was to resign, but the day before you see, 500 meg or 2 gigabytes worth of data going outbound to, let's say, OneDrive. Customer doesn't even use OneDrive. So you've got a lot of this sort of data that you can present to your customers, a value add, to sort of say, look, this is what this staff member did in the several days prior to their termination. This might be worth looking into because you don't use OneDrive. It looks like they've just made a massive data dump outside of your organization. And that can be very, very handy. But anyway, the data analytics, that is something that is imminently going to be available, which is great.
Cool. Well, that'll be a good diagnostic tool as well, right? Because you'll be able, if you're seeing that, the link is being saturated, I can't tell how many times we've had support tickets logged, and it's, you look at it and the pipe is being smashed, and it's because someone say BitTorrenting, or they're and it's been sitting in the background and it's just seeding and maxing out. This will be able to tell you exactly who and where. Especially with large sites, that can be really, really complicated, pinning that down. So this is really good, a value-added intelligence.
Yep. So a couple of the other things with the new portal, there are a whole bunch of extra features coming in, but there's going to be a few more that are quite on the technical side, like, for example, a couple of them that we've flagged, SSH access, so that you can actually get in and run traceroute and a whole bunch of different diagnostic tools like that directly from the node outbound. That can be invaluable. So that was something that was asked of us, so we obliged. And another thing that we're working on, don't hold me to it, but this is just a bit of a sneak peek. We're hoping to be able to present to you a little button that will pop open the web console of any of your upstream modems. So Dylan mentioned earlier, if you have a fiber to the node, you still need to have a VDSL modem upstream plugged in, and in bridge mode by all means. So what we want to present to you is a button that you can click on, which will open up the web interface so that you can power cycle that device, upgrade its firmware, turn on and off Wi-Fi, and do whatever you need to do. And that would go for a 4G router, etc. So that's another very cool feature that is sort of a watch this space. We won't promise it, but we've sort of 3/4 of finished the development on that actually.
Yeah, cool. That's kind of handy.
Yeah,
definitely.
One less thing that you have to sort of remote to site for, right? You can get a central portal that you can access those things. Makes you the 15 minutes that your tech saves can be pointed somewhere else, right? Pays for itself pretty quickly. Cool. Okay. Well, what we'll do is we'll just quickly cover the provisioning process, and then we're pretty much done, guys. But if you've got any questions, feel free to put them in. To order the service, it is very, very simple. You place an order via the partner portal. Now, your account manager can help you. They can raise a draft order for you. So if you need to do a multi-site one or something like that, your account manager can help you, but you can certainly go through the partner portal and raise this yourself as well. If you haven't had training, and we've got our the wonderful Meryl Palmer, our partner success manager, on the line, and she can organize training for you as well. So we can provide one-on-one training, both of the SD-WAN portal, right? So we can actually go through a personal run through, or of our partner portal on how to order it. But the first step is to place the order. The hardware is then shipped to site. So whichever hardware that you've chosen, if you've chosen hardware, if it's virtual, obviously we just send you the link to the ISO. You then configure the SD-WAN service via the portal, right? So we will provide you a service completion advice, or SCA. And from that, we'll have your portal login details and things like that. And if you require it, you can organize a engineering session with our team where we will actually guide you through the actual configuration. It's pretty straightforward, as you saw, but it's always good to have a helping hand the first couple of times that you do that. And then, the main piece there, you've just got to plug it in. So pretty straightforward. And that's really, again, like all of our products, designed for MSPs to streamline that process, right? So you don't have to, log into an individual device, do the configuration, then shift to the next one and the next one. Streamline the process, make it nice and easy, centrally manage it, all those bits and pieces. So that is, I guess, I've got a little training slide there. So if you do have you can book one-on-one training with Dylan as well. So you'll see in the bottom of all of our signatures that we have a training link, so you can actually organize that with any of our appropriate team members. Dylan will coordinate that for you as our partner success manager, partner support manager. See, everything's about partners.
Yeah, we'll send a wrap-up email as always with the recording and a link to the one-to-one technical training as well, so you can book that in if you need.
Cool. Well, John, thanks for joining us today. It was great to run through that. Looking forward to those new features. And thanks everyone for joining us. Hopefully you found that informative. If you do have any other questions, feel free to reach out to us. Happy to help. And hopefully the SD-WAN will help you solve some problems. Thanks again, guys. See ya.
Thanks, guys. See you next time.